I'll just have to be careful and dodge all this. I don't know what was going on. Okay, we were talking about debugging. We talked about syntax errors. And syntax errors are often not too bad to deal with because the Python error messages usually give you some pointers into the right direction on how to address it. And then we talked a little bit about type errors and how type errors could kind of sneak up on you. If I wrote a function to add two numbers together and I give it two strings that happen to be numbers, it's not going to work quite right. And then logic errors. Logic errors are the big ones. These are the ones that are tricky, where you hit run and everything works in the sense that it ran, but it didn't do what you wanted it to do. It did what you told it to do, but it didn't do what you wanted to do. And the tricky thing here is, was the issue with the way you coded what you wanted to do, or was it the issue with your idea in the first place? So it's hard to know, because there's the problem, then there's your solution to the problem, and then there's your code for it. Was the issue between here and here, or was the issue between here and here? Where was the issue? And it's hard to know. And these ones are tricky because you're not going to get error messages for these ones. These are the things that excuse me. These are the things that hopefully your tests help you resolve. You know, you write tests to kind of test a whole bunch of different cases, and maybe your code works most of the time, but in some cases it doesn't. You know, you've got some logic errors, you can fix those, but the tests kind of poke you along the way. The trouble with these is, yeah, everything seems like it's going to be working, but at the end of the day, something's off. Sometimes it could be obvious, like you hit run and your code gets into an infinite loop and it doesn't end. Okay, obviously something's wrong. But sometimes it might not be obvious. Sometimes you might not even notice there's an issue. Sometimes you finish assignment 1, you're like, yeah, everything seems to be working, you submit it and it's wrong. You know, something could happen there. First and foremost, there's no right way to go about doing this. This right here, this is the art of programming, is debugging, and how you manage it. One of the best things to do is eliminate the bugs before they happen. Like we were talking yesterday, what you could do is, you know, write a little bit of code, test often, make sure every little bit works along the way. That's going to eliminate a lot of bugs. Because when you write 3 lines of code and there's a bugs in that 3 lines, it's a lot easier to find than if you write 24 lines of code and it doesn't work. Good luck, right? So there are things you can do to hedge against having to debug in the first place. I'm going to talk about a few straightforward ways to do debugging, strategies that you may or may not have been doing already. Most people develop their own strategies for debugging with experience. You're going to do the same thing. There's no right way. But like with anything else in life, the more you practice, the better you get at it. And the good news is you're going to be practicing this a lot, right? So first and foremost, this is the easiest thing to do. And it blows my mind when people don't do this. So in other words, if you haven't been doing this, do this. Throw prints in there. Throw prints in your code all the time. If you hit run and it's not doing what you expect, print out the values of the variables. Are they what you expect them to be? If they are, good. If not, all right, well, that gives you a bit of a hint. If they're not, maybe move the print and check other variables. Throw a print in that if statement. When I run it, that if statement should be true, so it should run. But when I hit run, nothing was printed out, meaning it didn't flip off that if statement, meaning we never ran that. So what went wrong? The prints are a great way to guide you in debugging. But it's a very iterative process. You start with a broken function, you throw a print in there. Everything seemed fine. You move the print around. Everything still seems fine. Move it again. Something's off. All right, follow that. Why is that variable not what it is? Track that variable. Did it get modified here? Throw a print statement in there. No, it's the same there. Did it get modified over there? That's just kind of how you do it. That's the process. If you go back and you look at all my assignments during my undergrad, you're going to see, for each assignment, you're going to see dozens of commented out prints everywhere. Because I was too lazy to delete them. I just commented them out because I could never commit to deleting them. I don't know. But throw prints in there. It's a good strategy. It's a great strategy. So here. This function, sum numbers up to. All right? I hit run. Well, it worked for 0, but when I gave it 10, or when I gave it 5, it didn't give me 10. Or sorry, yeah, what? Add numbers up to. All right, so this function adds up all the numbers from 0 to n exclusively. For example, 5 should be 0 plus 1 plus 2 plus 3 plus 4. It gives me 10. But I didn't get 10. Why? Well, all right, well, first of all, what does it give me? Print, or it gives me 15. It's kind of giving me an idea what might be wrong. All right, so to start, those should be 0. Yeah, it's going to be, okay, makes sense. They're 0. That's good. All right. C, okay, at the start of the loop, goes from 0, 0, 1, 1, 3, 2, 6, 3, hold on, and 10, 4. But it is 10. So C did get to 10. Total was 4. Okay, so let's keep an eye on C. So we've got, okay, C. Okay, obviously I had 1 to C. Print C. Now, okay, we see 1, 2, 3. Okay, hold on. You know, we really never should have added, look, I printed out C here. And it's supposed to be 0 plus 1 plus 2 plus 3 plus 4. But this is saying 1 plus 2 plus 3 plus 4 plus 5. Meaning I added 5, right? Because immediately after this print, I add C to it. So what's going on here? The issue here is clearly with C. And I discovered that through throwing in and moving around a print just to kind of follow along what was going on. And it looks like I think I see the issue here. I incremented C before adding it to the total. Ah, there we go. If that felt fast, maybe it was a little fast, whatever. But the point, the takeaway isn't that you necessarily understood everything I was doing. The takeaway was that I used prints, and I moved the prints around. I printed out the values. I followed the values around. I hit run a couple of times. I kept track of what it should be, what I expected it to be, and what it was. And I found the discrepancy, which helped me narrow down, find out what the problem was. That's the strategy there. This strategy, this debugging strategy often follows a very common pattern. You form your hypothesis of what you expect some values to be at some point in your program. You add a print to confirm if you are correct or not. You hit run. You compare your expectation with reality. If they match, perhaps the problem's somewhere else. If they match, or if they don't match, investigate why they differ, and maybe repeat this process a little bit more, a little bit more, a little bit more, until you narrow yourself into where the issue actually is. Raise your hand if you've been doing this before, if you've done this. Raise your hand if looking at this you're like, God damn it, why didn't I do that yet? Well, all right, good. It sounds like everyone did it then. Good job. Pencil and paper. This is a great one. But this one's hard to do, not because it's pencil paper. No, that just might make it a little slower. What's hard to do is step 1. Don't assume anything. 9 times out of 10, has anyone spent way too long debugging their code? Okay, yes. Only to discover that the issue that you had that you've been hunting down was all related to an assumption you made before that you just never questioned in the first place? Yeah. Yeah, that's going to happen a lot. And so this is tricky. This is why I'm always saying, what does the code say? And sometimes in lab, I'll say, okay, walk me through your function line by line, what it's doing. And they'll be like, okay, well, in these lines here, it's going to start by doing, it's like, no, 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 stop it. One at a time. Okay, all right, so I'm going to loop over. One at a time. Seriously, one at a time, make no assumption. As soon as you start going, well, this chunk here, you've already failed. One line at a time. It's not to be demeaning about tell me one line. No, that's what you do. That's the process. If you think it's demeaning, I got news for you. That's just what you got to do. One line at a time. Make no assumption. What does the code say? And when you're doing it pencil and paper, you're the computer. You're looking at your code line at a time, and you execute everything. You keep track of the variables on pencil paper. You update them as you go, and you follow along. It's slow, but it works. Now, it's not slow. In fact, it might be ultimately faster to do that than it is to go and throw prints around for a while aimlessly. But it can feel slow because you're doing it on pencil and paper. It's easier said than done, depending on running your code repeatedly for debugging. A workaround is to not actually run your program on the computer, instead execute the program on paper. Yeah. Create a table, keep track of everything as you go. Big benefit of this is it does slow you down. That's actually a good thing. It slows you down, it makes you a little bit more careful and meticulous about what you're doing. It becomes a little easier to not make assumptions about your code. It's easier to make more assumptions when you're looking at it on the screen and you hit run and you jump. No, when you're doing it line by line on paper, it's a little easier. And it requires you to be very deliberate, which is a very good thing when it comes to debugging or coding in general. It may sound tedious, but it's really good. The point here is to take your time and think about every line of code. Rushing through and making assumptions is going to fail. It's not going to work. As half of you already confirmed, yeah, you've done that before. And I still do that all the time. It happens a lot. And then delta debugging. Another strategy is delta debugging. This one is simple. You delete your function. You put it somewhere else. Maybe you comment it all out. And then you add one line in at a time. If you're feeling brave, maybe 2 lines at a time. Then hit run. You might need to add a print. You might need to combine this with the print strategy. You add a print. Did it do what you thought it should? Add another line in. Did it continue to do what you thought it should? Add another line in, and so on and so on and so on. If you get to a point where you're like, well, I can't add one line. I need to add this block in. It won't make sense without it. Could you move that block to a function that you can test independently and confirm that's correct before carrying on? Like, there's a lot of things that can go on here. But this is basically like start over, do one line at a time, make sure every line works as intended as you go. And if you get to the end and it's still not working, you probably made an assumption. You probably skipped a step. Do it again. Slow down. And here's a big one. Rubber duck debugging. This isn't a joke. This is real. There's a Wikipedia article for it and everything. And look, they've even got a rubber duck there. Rubber duck debugging. This is the idea. When I was taught this, it was called like teddy bear debugging, but there's no Wikipedia article on that. There's a rubber duck one, though. It's the same idea. Has anyone in here been working on the assignment, and maybe you're in the lab with someone next to you, or you're sitting next to someone who's also working on the assignment, and you've been beating your head against that keyboard for a while, and you just turn to the person next to you and you're like, look, just something's wrong. Just let me, give me your eyes here for a second. And they're like, okay, fine. And they look at your code, and they're not going to know what the hell they're looking at. It's your code, right? If you're debugging it, chances are you rush through. It's terrible looking code. It's hard to follow. But here's what they can do. They can listen to you. And what you do is you explain to them, one line at a time, what your code's doing. And it is hilariously common for that person to be like, okay, so on the first line, what we're doing is we're setting the value of this to x, y, z, And then on the next time, we're taking the... Okay, I see the problem. All it took was them to articulate out loud what their code was doing, even though I said go through your code line by line. You're doing it in your head. Go through line by line on paper, fine. If you actually talk out loud, now you're not always lucky to have a friend sitting next to you, but what you might have is a rubber duck. So talk at that rubber duck. Explain out loud what you're doing. You don't make assumptions. You have to be slower because you're vocalizing your thoughts. Obviously, your mouth can't move as fast as your brain. And you talk out loud, yeah, you're going to find the solution. This isn't a joke. This is common. You'll see programmers with little rubber ducks. It's like a thing in programming. You want to know why the little logo for the course is a duck? It's the rubber duck, right? See, a little duck right there? It's a duck if you can't tell. It's not a joke. It's amazing. Sometimes you have a friend. Sometimes you have your mom or your grandma. I don't know. You have a pet. Sometimes you have a rubber duck. Get a rubber duck, and you'll be all set. You'll be the best programmers in the world. They'll help you debug. Any questions about debugging? Now, I'm going to show you something here real quick. Nope. So I'm going to load up PyCharm. PyCharm, it's just an environment to program in Python. We've been using Colab. This is another one, PyCharm. It's really popular. It's great. And a lot of these programming environments have built-in debuggers, tools that aid in debugging. Now, contrary to what the name might lead you to believe is it ain't going to debug your code for you. But it's a tool to help you debug. And I'm just going to see if I can load up an example real quick. This is 340. Give me a moment while I load up, my God. Okay, I don't have any other one on here real quick. All right, so okay, and I'm going to hit the debugger. All right, so I'm running this code, but I'm not. Hold on, they've changed how this looks. Problem, service. Ah, okay, great. I'm running the debugger, and here's what happened. I called this function, and this is the function I've set the debugger on. Now, to be clear, I'm showing you this for the sake of letting you know that this exists. I'm not expecting you all to go get PyCharm, download this, and use a debugger. It's a pretty beefy tool. It's a little overkill for our needs in 161. If you feel inclined to do this, by all means do so. But don't think that you should be getting this tool and using it right now. But I'm letting you know that this exists. So I set what we call a breakpoint, which means go run the code, but stop here. And this is actually like the first line of code within the function. And it is. So the program has run, and it's waiting. It hasn't quit. It's just stopped. It's paused. And it's telling me you have 3 variables, index, parent 1, parent 2, and these are their values. It's showing me. I can say step, step, and you can see it ran an if statement, it ignored it, if statement, it ignored it. And now we're on this line. I'm telling it, run one line at a time, and I'm keeping track of the values down there. Let's do that. Oh, well now, we've created a new variable that's a copy of parent 1. And do it again. Okay, and now I've got child 1, child 2. They've been changed, haven't they? Yeah, we've got 0, 1, 8, 9, 10, 11, and 6, 7, 2, 3, 4, 5. So it's letting me watch the values of these variables like in real time as I step through my code, which is pretty great. There's a lot more you can do with this too. You can actually go and like modify the values to see how it affects. You can ask specific questions. If I can find out, they've changed the UI in PyCharm a little bit. I can't figure out how to do what I'm thinking of, but you can add like Boolean conditions to your variable to check if some condition is true or false as you're stepping through. There's a lot of bells and whistles you can use. It also has like a stack trace over here, which is something we'll learn about later. Point here is there's a debugger. It's a very powerful tool to help you debug. And just stop it for now. Excuse me. Don't feel the need, if you're like, wow, that's cool, I want to play around with that, go ahead. By all means, feel free to do so. You don't feel like you're not missing out in 161 by not using it. It's a pretty beefy tool. Maybe next semester you get familiar with it when we're doing Java, because we'll be using an IDE, a development environment, kind of like PyCharm for Java. Then you can learn a little bit more and play around a little bit more with it. But debuggers exist. And it's a tool that's definitely, you're going to want to figure out sooner rather than later. Just don't worry about it right now. Okay. Any questions? Any more questions, thoughts, concerns, comments about debugging? I probably didn't tell you anything you didn't already know, that you wouldn't have already kind of thought of on your own. But sometimes it's nice to see some, well, maybe you didn't think about rubber duck debugging, but it's a good one, trust me. Sometimes just seeing like delta debugging mentioned or printing mentioned, it just kind of reaffirms, yeah, okay, what I've been doing is good. That's a good debugging strategy. Or maybe I should do that more. I thought I was kind of being cheesy when doing it, but no, it's good. Debugging, great. All right, file I/O. File I/O, I/O meaning input output. We know how to read input from a user. We know how to store data in variables. We know how to maintain data and manipulate data in things like lists, right? Our data structures. What if I have a large amount of data? I want to read in like hundreds of lines of data, kind of like the Starbucks data, right? I want to read that data in. And imagine I said, okay, yeah, do that with an input. Are you really going to sit down and manually enter one line at a time, type in the hit enter, type in, hit enter? No, that's nonsense. We want a way to read in the data from a file like automatically, like you did in assignment 1. Text files. Basic, plain old text files are a great way to store text data. Usually they have a file extension .txt, but the actual file extension doesn't really matter. But a basic old text file. Now, when I say text file, I don't mean like a Microsoft Word file, like a .doc. No. That's not a plain old text file. That has a lot of other stuff in it that's just going to mess you up. I mean a plain old text file. I mean, if you open up Notepad on your computer, that's a text file. You save it, it's got a txt, great. We can load text into the computer. Most of what we are about to see will work with many different types, not just text, but I'm just going to show you anyways. So here's how you do it. Here's how we can open up a text file. Now, This is assuming we've got a file called somefile.txt that exists. So here's what I'm going to do. New text document, somefile.txt. Right, I just put some text in a text file. It's kind of hard to see. I realize it's small. Can I zoom in? Right, it's just a text file. Great. It stores textual data. All right, I saved it. I'm going to go here. Here? Okay, upload. Some file. There. Yeah. So I've uploaded it to Colab so it can load it in itself. So it's uploaded in Colab, but it's not in my code. It's just, it's there. Somefile.txt. There we go. Copy that, copy that. So I open the file, and then I print out the file. But it's clearly that right there isn't the text in the file. I loaded up the file and stored it in a variable called myFile, and when I printed it out, it gave me all this stuff, whatever. And then I asked the type, and it's like, oh, this class, text IO wrapper, whatever. It's telling me it's a text file. Great. But that's not actually the data there. Hey, anyone want to take a wild guess what this R means? Now, this is like an old convention that's just stuck around. Anyone want to take a wild guess? Read mode. Yep, absolutely. What do you think we would put if we wanted to write to the file? W. See? You're smart. Yeah. So read mode. Oh, did you read that? Did that get, or did you just kind of trust your gut? Pardon? I knew. You knew. Nice. So this assumes that the file we want to open exists where Python is looking. If it doesn't, it's not going to load anything. It's going to say, I can't do it. Let me show you. File not found. No such file or directory. Some file, ASD, etc. So no, I do it with the actual file that exists, and it's happy. Great. So there we go. Activity, well, here. Actually, yeah, do this activity. Now, I'm going to do it here together just because it can get hairy. So open your file, okay. Try using the methods read lines. So if I do my file, let's get rid of this here. If I say my file dot okay, there we go. If I read the file, it'll actually store, it'll take that and put it into there. Type, well, that's a string. I wonder what happens if I, yeah. And here I'm showing it to you. I didn't print out the string. I'm showing you like the string more, what it looks like raw. And see how you see like the slash ends in it, right? That's the new lines, remember? Which is kind of neat. So we got read. What about read lines? Read lines. I wonder what that's going to do. Print, read, file. So this will actually read each line. The line ends with the new line character. And it'll store each line in a list. Sorry, it stores the file's contents in a list where each element in the list is one line of the file. Do you see? The first string is hello, new line, it ends. Then we have another element. Here, let me do this, len. How long is this list going to be? 4. Why? Well, because there were 1, 2, 3, 4 lines in it. Cool? Cool. How do I want this to go away. How do I make this go away? X, okay. What if I do read line? Oops. Read line, well that reads only a single line. So, I mean, what I could do then, maybe if I cared about that, I could say for in I'm trying to think of a good example here. How do I do this? I'm trying to remember. Oh, it's because it's there. Now, there's some kind of funny things here that happen. First of all, you'll notice that, like, okay, if I use a file in a for loop, it'll read one line at a time. But there's a lot of weird stuff going on here. First, let's talk about the extra spaces that we see in the output. This is a text file. New line, I think this is great. New line, there's 2 sets of new lines. Does anyone know why? By default, whenever you use the print function, it adds a new line to the end of any string that you're printing. But each of those strings we saw contained a new line at the end. So it was adding a new line after the new line. So it had the string, and the string contained a new line, and then print added another new line. So that's why it printed it out, went to the next line, went to the next line. That's why. But you might also notice this didn't start at the beginning of the file, right? The first line of the file was hello, but it didn't print out that hello. Now, if I do this, it will. But it's because file readers are kind of funny. Whenever you create a file and you want to read from it, the file knows what line it's currently on. And as soon as you read a line, it goes to the next line. And if you ask it to read another line, it carries on from where it left off. So what I did originally was I read a line. So the file knew, oh, okay, so now I'm at the next line. And then when I went in the for loop and said, okay, read the lines in the file, it started off where it left off. So it skipped that first line. And now if you say, okay, after all that's done, okay, great. Well, I want to read from the file again. Read file equals my file.read. Let's just read the whole thing again. Remember, read everything in. Print read file. I mean, how come nothing's coming up after, like I just said, read from the file again, and nothing's happening? I'm not getting any input after the done loops was printed, even though I'm saying, okay, read from the file and print it out. Well, that's because we finished reading from the file. That little like read head, you could call it, that thing that kept on track of where we were, well, once I went through with the loop, that thing that kept track of where we were in the file was at the end. And so when I said, okay, read from it, it goes, okay, here's the rest. Here's nothing. There's nothing left. Because files work like that. If you really want to start over, if you say, well, no, I want to read from that file again, you have to open it back up. There. So now, if I really wanted to read again, I need to open it back up. Cool. Now, this time there was no extra spaces between them because this is just one big string that contains new line characters. There is one new line character that this added on at the end with the print. But, yeah. I want to, your quietness and blank faces concerns me, that I don't know if you're happy or unhappy. Just to make clear, the reason there's an extra new line here and we didn't see here was because here. We can clearly see there's no extra funny new lines in between there, right? But there are here. Every time print is called, it adds a new line to the end of what it just printed out. And this string here, line, contains the character at the end, a new line character. So when you print, pause on that. Let's go down here. I read the whole file in here. I'm gonna show it to you raw, so you can see this new line. So this is the string Python has. But when I say print it out, Python goes and writes these /n's as actual new lines, right? That's why we see it like that. This is why we don't see the /n's when we print it out, because that's just, it means go to a new line. Those /n's exist on this line. So Python says print out this whole line, which is some string, like it says hello, new line. So it goes hello, new line. And then at the end of every print, it adds a new line. So that's why we have two new lines. The one that was embedded in the string already, and then the one that Python added for you. The reason we didn't see it down here was because, well, I only printed out the whole string once, as opposed to printing out multiple lines multiple times. This read one line at a time, printing it out each time. This read the whole file into one big string and then printed it out once. That's why it looked a little different. Now, if we look at my file, there's a lot of methods and whatnot that you could use with it. So I'm obviously not being very exhaustive here, but I'm just letting you know. When you're done with your files, it's important to close them. It's easy to forget, but it's important to close. Now, it's not so important to close when you're reading from a file, but when you're writing to a file, it's very important to close your file. And I'll hit more on that in a moment. So, writing to a file. Okay, so here we go. Now, first, right here, these are the files that Python knows about right now. Do you see another file name .txt written over here? Is there a file over here called another file name? No. But when I'm writing to a file, and we know that we're writing because we've got that W, when I hit run, and then over here we probably have to hit refresh, it popped up. So Python can create a file. I mean, I've done nothing with it. If I open it up, there's nothing in there. But Python's happy to create a file. And now I can go and I can say, okay, my other dot write. I hit run. I open up the file. And we see nothing in there. It's kind of weird, right? Well, here's a little bit of a story. What time? Do we have enough time for this? Oh, yeah. And you know what? Oh, Story time. There we go. All right. So, imagine, I'm probably not going to be on the video right now because the camera's up so high, but whatever. When you do I/O, any input-output, it's really slow on the computer. It's really slow. Let me show you really quick. I'm not even talking about file I/O. I'm talking even just printing to the screen. If I have for I in range, print I, print done. Nope, print done. Well, that was pretty quick, right? Okay, it's done. It took like a few seconds to run, right? Printing out 10,000 numbers. But now I'm just going to use a keyword here, which means pass, which means like, okay, do nothing. If I run this same code, this loop is going to run 10,000 times, but it doesn't take any time to run at all. Let me go back, print 100,000. Okay. There, it took about 12 seconds to run, no big deal. And here, just for the sake of argument, if I mod 100, no. There. I only printed out in every 1,000. Yeah, I only printed out every 1,000. Right, so it would skip every number between 1,000 and 2,000. It only printed out every 1,000th number, okay? But the loop still ran 100,000 times. But when I printed out every number, it took 12 seconds. When I printed out every 1,000th number, it took no time at all. And if I printed out no numbers, it went even faster. But the point is that loop still ran the same number of times. So the computers really suck at I/O. Now, this will also be true with a file. It's going to be even slower because the computer needs to go to the file somewhere on your computer, update the contents of the file. If I'm writing 10,000, 100,000 lines to that file, that's going to be very slow. All right? So, here's what they do instead. They say, all right, well, what if instead we create this temporary buffer? Kind of this like, it's a buffer, where instead of writing to the file every time we want to write to the file, what if we don't do that? What if instead we write to the buffer? And the buffer is just some memory address. It can do that real fast. It's quick. All right? And then every once in a while, flush the buffer to the file. So here's what will happen. Instead of saying, okay, I want to print all 100,000 numbers into the file, instead of saying, okay, 0, add that to the file. 1, add that to the file. 2, add that to the file. We're going to have to write to the file 100,000 times. Instead, what we do is we write to the buffer maybe 100,000 times, but then we write to the file once. Even though the same number of things are going to get written, it's the act of going to the file and adding things every time is so goddamn slow, that's a problem. So we have this buffer situation. And so when I had the file open, that data that I said write to the file didn't get flushed. It's sitting in the buffer. I need to actually close the file, or I'll close it. There's also, I believe there's flush. Yeah, flush will also work. But closing it will update it. Well, now I'll probably have to like refresh. No, let me. Yeah, there we go. Now it's actually there. When I didn't close it, it was stuck in the buffer. So we had to be careful about that. So that's a little bit about writing to a file. You can write to a file one line at a time, or there's like write lines where you can give it a list of strings and it'll write each line in its own, each element in the list on its own line. There's a lot you can do. I'm not going to go and show you everything you can do, but write and write lines are probably your most common ones you're going to want to use. And I showed you how to do it. Now here's me talking about flushing the buffer and whatnot. Cool. Any questions about reading and writing to a basic text file? All right, where CSV? All right, we'll end here for now because I don't want to start CSVs with 2 minutes left. All right.